So we're going to be using these properties all class today. So on my display, I went ahead and just kind of put them in the corner of each of my screens. I want you to either pull up your textbook and go to one of these pages and pull up the properties, or if I don't know, you should be able to get to your textbook easily. You're supposed to be using it this semester, but if for whatever reason it's harder to get to, or you can't split your screen or whatever, go ahead, take a picture of this right now on your phone and have it beside you all class, because I'm going to be referring to these. But an important thing to notice is that really once you understand one of the sets of properties, the other one is exactly the same. So what this first one is saying is if you take the log of 10 raised to the power x, that's equal to x. Similarly, if you take the natural log of e raised to the power x, that's just equal to the power x. The opposite of that is also true. So if you have 10 raised to the power of log x, that's equal to x. And similarly, if you have e raised to the power of ln x, that's also equal to x. Oops, didn't mean to do that. For any positive x. So it's important to notice these conditions on the side. Next, we get into the product property. So if you have the log of a times b inside of the logarithm, you could go ahead and write that as log of a plus log of b. And then the quotient rule would be log of a divided by b is equal to log of a divided by log of, or minus log of b. So you could go ahead and separate those values in different logarithms. Same thing with the natural log. If you're multiplying on the inside of the natural log, you could separate it with two natural logs in addition. And if you're dividing, you could go ahead and separate it with subtraction. Lastly, if you had the log or the natural log of some value b raised to the power of p, then you could pull that p out in front, and then you have p times log of b. Same thing with the natural log. You could pull that p out front, and then you have p times ln of b. Notice that inside the logarithms and the natural logs, there is no addition or subtraction happening. So if there's addition or subtraction inside the log or inside the natural log, we cannot simplify it any further. Okay. Any questions on these properties? Like I said, we're going to be using them all class, so have them beside you. I guarantee that most of your questions will be able to be answered just by me saying, oh, we used property 2 here. Unless you don't understand the properties, and if you don't understand the properties, that's perfectly fine. I'm sure you're not alone. Feel free to ask me questions about that if you end up not understanding it. Okay. Moving on. Like I said, I just took, one of them because they're the same for both natural log and common logs. I just put it in the corner of my screen. It's hard to find a spot to get it really out of the way, but in order to, so we could reference it. So for problem 1, use properties of logarithms to expand a given expression as much as possible and write it in terms of log of x, log of y, and log of z. If it's not possible, say so. X, y, and z are assumed to be positive. Okay. So what we have to do, we look at A, we have the log of 5z over x. I can rewrite this as the log of 5z minus the log of x. That's using property 4 up here. I took my division and I wrote it as a subtraction. Okay. We still have to get log of x isolated, log of y isolated, and log of z isolated. This problem doesn't have y, but we have to get the 5 and the z separated in here. And we can go ahead and do that by property 3, which is the product rule. So we have log of 5 plus log of z minus log of x. And that's your final answer. Any questions there? Okay, problem B. All right, here we have log of x to the power 5 y cubed z squared. So what's happening here is inside of our logarithm, we have multiplication and values being raised to a power. So we're going to have to use property 3 and 5 on this one. So this is equal to, I'm going to go ahead and use my property 3 first, my products. So log of x to the power 5 plus log of y cubed plus log of z squared. Now I'm going to use my property 5 up there for my powers. And each of those powers on my x, y, and z, I'm going to pull out of the log and pull in front of it. So we'll have 5 times log of x plus 3 log of y plus 2 log of z. And that's our final answer. Any questions there? Good. All right, problem C. We have the log of y times z over the square root of 4x. Okay, this one looks a little hairy. It'll take a couple extra steps. We're going to have to combine even more properties, but I have no doubt that you could do it. The first thing that we'll go ahead and do is we'll get it out of a fraction. Okay, so we'll have log of yz minus log of, I'm going to write it as the square root of 4 times the square root of x, right? Since we're multiplying in our square root, I could go ahead and separate it as the square root of the two values being multiplied. And now from here, I'm going to separate the multiplication. I'll separate this multiplication of y and z and square root of 4 and square root of x by using property 3 up there. So this is equal to log of y plus log of z. We have to be careful here because we have minus this whole value happening. So we're going to have minus parenthesis. We have to keep everything in the denominator still clumped together. So minus log of the square root of 4, which I'm going to write as 4 to the power of 1/2, plus log of x to the power of 1/2. I'm rewriting all I did here, in addition to rule 3, where I broke up the product inside the log, all I'm doing here is rewriting what's inside of these logs with exponents instead of square roots. Okay, this is equal to log of y plus log of z. This first half of the equation is all done. We don't need to manipulate it anymore. This second part, we need to get, I guess we could leave this, but to make it look nicer, we're gonna, we'll take this actual square root, and then we'll do, we'll get rid of this exponent here. So we'll have minus, remember, big parenthesis, the denominator needs to stay in the denominator, so we need to keep all of the stuff being subtracted together. Log of square root of 4 is 2, plus, now I'm going to use my fifth property up here, which will be 1/2 log of x. And the very last thing that we can do to go ahead and make this look a little better is we'll distribute this minus sign. So we'll have log of y plus log of z minus log of 2 minus 1/2 log of x. And this is how we expand that logarithm or that expression. You might be wondering why it would be useful in order to expand these, because it goes from looking, I mean, not simple, definitely not simple, but more condensed to this long, drawn out, complicated thing. This is useful if you're solving equations. If there's only one thing inside of the logarithm, it's usually better than multiple things, especially when you have a lot of variables or unknowns or in your function. So that's why it's important to know how to expand these out. Okay, problem D. We have that the log of y squared z over x minus x squared. Am I able to rewrite this with only log of x, y, and z? Am I able to separate this at all into separate logs?
No.
No, good. So this one is not possible. And the reason is because we have subtraction. Inside the log. Any questions so far? Okay, problem E. We have the log of x squared plus y squared. Can I simplify this or not simplify, sorry, expand this?
No.
Good, no, so not possible. We have addition inside the log. Okay, any questions on those two, on why those are not possible? Okay, problem F. We have the log of 100 y times the square root of x. Okay, how can I go about separating that multiplication inside my logarithm?
Using like step 3.
Using property 3, good. I could rewrite this as log of 100 plus log of y plus log of x to the power of 1/2. Good. What is the logarithm of 100? Anyone know?
Is it 10?
Good, it's 10. And you know that because you could ask yourself, 10 raised to the power of what equals 100, and it's 10 raised to the power, oh, sorry, it's 2. 10 raised to the power of 2 is equal to 100. Okay. Now we have plus log of y, and then plus, how can I rewrite this last term here, log time of x to the power of 1/2?
Is it plus 1/2 log x?
Good, it'll be plus 1/2 log of x. That's using property 5. Any questions there? Okay, problem G, we have log of 10x over zy. What's my first step in rewriting this or in expanding this?
Using rule 4.
Good, rule 4. Let's get rid of that fraction. So we have log of 10x minus log of zy. Can someone tell me what my next step would be?
Property 3.
Property 3, good. So we'll get rid of that multiplication in there. So we'll have log of 10 plus log of x minus, in parentheses, remember we have to keep our denominator together. So log of z, I'm running out of space, minus log of y. Okay, give me more space. Okay,
Wouldn't it be log z plus log y?
yes, sorry. Yep. Thank you. Okay. Now from here, what's the logarithm of 10?
1.
1, good. 1 plus log of x. Now go ahead and distribute that negative. So we'll have minus log of z minus log of y. Okay. Any questions there? Oops. Okay, moving on to the next page. Okay. Here, we're essentially going to do the same thing. Use the properties of logarithms to expand a given expression as much as possible. Write the terms in ln of x, ln of y, and ln of z. If it's not possible, say so. X, y, and z are assumed to be positive. So instead of logarithms, we have natural logs. And as I mentioned earlier, it's the same set of rules, just wherever you see log, you put in ln. And really, the only ones that change are these two. And it would be ln of e to the power x equals x, and e to the ln of x equals x. But the for positive and for any x still apply here. Okay. Problem A. We have the natural log of z squared over 2x. What's my first step in expanding this?
Using rule 4.
Good. Using rule 4, we'll go ahead and take ln of z squared minus ln of 2x. And just so you know, you certainly can, keep it as a fraction and then and use rule 3 first and rule 5 first on this. I like to just get it linear first and then, or all in one line, not fractions, and then deal with it from there. Okay. And this is equal to, what's my next step in expanding this first term?
Using rule 5, so it'd be 2 times the natural log of z.
Good, 2 times the natural log of z. And then we have minus parenthesis. How am I separating my 2 and my x?
With rule 3.
Good, so we'll have ln of 2 minus ln of x. From here, just go ahead and distribute that negative, plus ln of x. Distribute that negative sign. 2 ln of z minus ln of 2 plus minus ln of x. And that's your final answer for that one. Any questions there? Problem B. The natural log of the square root of x to the power 3, y to the power 3, z. Shorten this up a little bit. Okay, I am going to go ahead and before I even deal with my natural logs, I'm going to deal with my exponents. So I'm going to rewrite this as ln of x to the power 3, y to the power 3, z, all raised to the power of 1/2. And what do you do when you have an exponent raised to an exponent?
Multiply.
Good, we go ahead and multiply those exponents. So we have natural log of x to the power of 3 over 2, y to the power of 3 over 2, and z to the power of 1/2. Now, from here, which logarithm property can I use to start separating these, start expanding these?
Three.
Good. So we have the natural log of x to the power of 3 over 2 plus natural log of y to the power of 3 over 2 plus natural log of z to the power 1/2. Now what property do I do to get rid of my exponents? Or to get them out of the log?
Would it be 5?
Yep, it's 5. So I'm going to go ahead and take my exponents. 3 over 2 gets multiplied by natural log of x, and then plus 3 over 2 gets multiplied by the natural log of y, plus 1/2 gets multiplied by the natural log of z. Oops, z. And that's your final answer. You know you're at your final answer. Probably maybe should have explained this more in the beginning, but you know you're at your final answer when you only have ln of x, ln of y, and ln of z inside your natural logs, or your in the first part log. Okay, problem C. Can we expand this? We have the natural log of x plus y squared.
No.
Good. Not possible. Someone else tell me why.
Because you can't add in parentheses.
Good. We have addition in the natural log. So we can't simplify it. Okay, next, problem D. We have the natural log of e times x times y over 3z. What is our first step in expanding this?
Rule 4.
Good. So we'll take the natural log of exy minus the natural log of 3z. Now what's my next step in expanding?
Step 3 or property 3.
Yep. So we'll have the natural log of e plus the natural log of x plus the natural log of y minus parenthesis natural log of 3 plus natural log of z. Okay. This down just a bit. Now from here, I'm going to do two things. First, what is the natural log of e?
Is it 1?
Yep, it's 1 because e is, secretly raised to 1, and so that would make our x1 up here, So we have 1 plus the natural log of x plus the natural log of y. Now I'm just going to go ahead and distribute this negative. So we have minus the natural log of 3 minus the natural log of z. And that is your final answer for D. Okay. Any questions on that one? Okay. For E, we have the natural log of e squared y times z to the negative 3. What's our first step in expanding this?
Rule 3.
Rule 3. Yep, we'll go ahead and separate those products. So we'll have the natural log of e to the power of 2 plus the natural log of y plus the natural log of z to the negative 3. Okay, so now let's take it term by term. We have the natural log of e squared. What is that equal to?
2.
Good, it's equal to 2, and we know that from property 1, plus the natural log of y. Now, for this last one, we have the natural log of z to the negative 3. How can I expand that?
Using property 5.
Using property 5, good. And notice that even though we have a negative exponent, we're just going to pull that negative out. So we'll have minus 3 times ln of z times the natural log of z. And that's your final answer there. And this makes sense that we have minus here, because remember, when you have an exponent with a negative value, you can make it positive by bringing it to the denominator. So really, this here is the same as the natural log of e squared times y over z to the power of 3. So it does make sense that we end up with a minus sign in our expansion. Any questions? Okay. Problem F, we have the natural log of x over 3e. What's my first step in expanding this?
Property 4.
Property 4, good. We'll have the natural log of x minus the natural log of 3e. We'll keep the natural log of x minus parenthesis. What's my next step in expanding the natural log of 3e?
Property 3.
Good. So we'll have the natural log of 3 minus the natural log, plus the natural log of e. We could go ahead and I'm going to distribute this negative sign and also simplify my last term. So we have the natural log of x minus the natural log of 3 minus, what is ln of e equal to again?
1.
1. Good. And this is your final answer here. Okay, moving on to problem G. We have the natural log of 1 over x cubed y. What's our first step here?
Property 4.
Good, so we'll take the natural log of 1 minus the natural log of x cubed y. Natural log of 1 is going to stay as is. We have minus. How do we get rid of this multiplication inside of our natural log here?
Property 3.
Good, so we'll have the natural log of x cubed plus the natural log of y. Okay, now from here, we have the natural log of 1 we'll distribute our negative and we'll deal with expanding that middle term. So we'll have minus, how do we expand this middle term?
Property 5 with a x and with a 3 in the front.
Perfect. So times 3 ln of x, and then we have minus ln of y. Did I confuse anyone there when I did 2 steps at once? If I did, let me know and I could break it down. Okay, moving on to problem H. We have the natural log of square root of e over x times z. What's our first step here?
ln e to the 1/2.
Ln of e to the power of 1/2. Good, already putting it in an exponent for our next step. Perfect. Oops. And then we have a minus ln of x times z. So that was using property 4 again. Now from here, how do we expand this first term?
Using property 1.
Yes. Yep. So we have 1/2 minus, how do we expand the second term?
Using property 3.
Good. So we'll have ln of x plus ln of z. Okay, now from here, we have 1/2 minus, we'll go ahead and distribute this negative, ln of x minus ln of z. And that's your final answer there. Any questions? Okay, moving on to the next problem, problem 3. Okay, fold the given expressions and write as 1 logarithm if possible. If it is not possible, say so. A, B, and C are assumed to be positive. Okay, so now this is a little backwards from what we were doing. So, okay, so before we were starting on this left-hand side of all these properties, and we were moving to the right-hand side. Specifically, these bottom 3 we're going to look at for this, this problem, but we want to start on the left-hand side and then fold it into the, start on the right-hand side and then fold it into the left-hand side. I don't know actually if your left-hand, right-hand sides are the same as mine, but we're going to start with it expanded and fold it to be more condensed. Okay, so put that there so it's a little bigger. Problem A, we have log of A over log of B. Does this look like anything on this side of our properties?
No.
No. So this one, it's not possible. Not possible. Problem B. We have 2 times log of A plus, minus 3 log of B. Okay. Does this look like anything on the right on this side of our properties?
Yes.
Okay, which one? It could be multiple, but what's one that stands out?
5.
5.
5, good. Let's do 5 first. So we're working pretty much exactly backwards as before. So we're going to work with property 5. So we'll have log of what? What does 2 log of a become?
Log a squared.
Log of a squared minus, what does 3 log of b become?
Log of b cubed.
B cubed, good. Okay, now from here, this matches property 4. So we'll have now log of a squared divided by b cubed. Any questions there? Okay, for C, we have the log of a times the log of b. Does this match anything on this side of our properties?
Yes. Oh, no, I lied.
Okay, no, good. Good answer. So this one is also not possible. Problem D, we have 1/3 ln of A plus 2 ln of B minus ln of 10. Okay, what property does this match?
Is it 5?
Yep, so one of the properties that it matches is 5. So how do I rewrite 1/3 ln of A as a natural log of what?
The natural log of a to the 1/3 or the cubed root of a.
Good. Either will work. It doesn't specify any specific way we have to do our roots. All right, what does 2 ln of b become?
ln b squared.
Good, and then we have minus ln of 10. Okay, now what other rules do we see happening?
3 and 4.
3 and 4. It really doesn't matter. Actually, it does. We have to go left to right. So let's do our property 3 first. So we'll have ln of a to the 1/3 times b squared minus ln of 10. And now property 4 will have ln of a to the 1/3 b squared divided by 10 as your final answer. Okay, any questions there? Next problem. Okay, now we're solving expressions for x or t. We have to give the exact answer as well as the approximation rounded off to 3 decimal places. Okay. Problem A. So to solve logarithms, we want to use our properties, make use of our properties, we especially make use of property 2 and property 1 for these. So for problem A, we have 5 to the power x equals 500. We can't take the xth root, like what does that even mean? So what we do here is we go ahead and take the logarithm of 5x. So we'll take the log of 5x, and whatever you do to one side, you have to do to the other, times equals the log of 500. And then when we can now expand the log of 5x to be x log of 5 equals log of 500. Now we could treat x as a normal variable. It's, on our standard line for computing or for solving. And then we have logarithm of 5 and log of 500. But remember, those are just numbers. So we're just going to treat them all as one unit. Okay, so, if it makes you feel better, highlight this in one color and this in another color, just to emphasize that it's two separate numbers and they're just numbers. They're nothing to trip you up. Now we'll divide each side by log of 5. Divide by log of 5. And we'll get x equals log of 500 divided by log of 5. Now go ahead and put that in your calculator. So we did this couple classes ago, I think, where we practiced putting logs in our calculator. Where's my guy? Oops. Okay, so log of 500, move outside of the parenthesis, divided by log of 5 equals. Oops. Log of 500 divided by log of 5 equals about 3.861. Okay. Just for the sake of time, I'm not going to plug each of those into the calculator. If you have calculator questions, I'd gladly stay after with you. Problem B. Okay, so now this one looks a little different. This is pretty much how you solve exponential functions, which we covered last section. We have 1200 times 1.15 to the power t equals 2400. Remember, we didn't know how to solve this last chapter, but 1200 would have been our initial value. 1.15 would have been is the growth factor, and then we're setting it equal to this value. Okay, so to solve this, we'll divide each side by 1200 first. So we have 1.15 to the power t equals 2. And now from here, we'll take the log of both sides. Log of 1.15 to the power t equals log of 2. Log of 2. We'll use that rule or property 5 for our logs. So we'll have t log of 1.15 equals log of 2. Divide both sides by log of 1.15. So we'll have t equals log of 2 divided by log of 1.15. And this is about equal to, problem B is about equal to 4.959. Okay. Problem C, we have 250 times 0.81 to the power t equals 125. So here, our initial value is 250. The growth factor is 0.81, and we're setting that equal to 125. Divide both sides by 250. So we have 0.81 to the power t is equal to 1/2. Now from here, take the log of both sides. Log of 0.81 to the power t equals log of 1/2. Pull that t down, bring it out in front. So we have t log of 0.81 equals log of 1/2. Divide both sides by log of 0.81. So t is equal to log of 1/2 divided by log of 0.81. If you plug that into your calculator, you should get that that's about equal to 0.404. Questions there? Okay, moving on. Problem D. We'll go ahead and divide both. We have to get our x's on one side, even though they're in the exponent. So we'll divide both sides by 5x. So divide by 5x and divide this side by 3 times 5x. And I'll also divide this side by 3. That way we end up with 7x over 5x equal to 4 over 3. So these two divide out and these two divide out. We could rewrite this as 7 over 5 raised to the power x equals 4 over 3. Okay, now from here we take the log. We have the log of 7 over 5 to the power x equals the log of 4 over 3. And then we have x times the log of 7 over 5 equals log of 4 over 3. Divide both sides by the log of 7 over 5. So we have x equals the log of 4 over 3 divided by the log of 7 over 5. Plug that into your calculator. Make sure you have parentheses around your denominator there. And it is about 0.855. Okay. Problem E. Problem E, we have 90 times 0.5 to the power of t divided by 10 is equal to 40. Okay, so we'll divide both sides by 90. So we have 0.5 to the power of t over 10 is equal to 4 over 9. Okay, so we'll take the log of both sides. So we have the log of 0.5 to t over 10 is equal to the log of 4 over 9. Using that property 5, which I hope you guys have come to love, we'll pull this exponent out. So we have t over 10 times the log of 0.5 is equal to the log of 4 over 9. So this one's a little funky because we have another extra step, but we'll go ahead and divide both sides by log of 0.5. So we have t over 10 is equal to the log of 4 over 9 divided by the log of 0.5. And then lastly, we'll multiply both sides by 10. So multiply by 10, multiply by 10, and we have t equals the log of 4 over 9 divided by log of 0.5 times 10. And you could just do that times 10 in the numerator. And that's your final answer for this one. And then lastly, problem F. Oh, sorry. This is about equal to 11.699. Lastly, problem F is 490 times e to the power of negative 0.098 to the power times t equals 100. Okay, remember this is our continuous, it's another exponential function, but we have our continuous growth rate happening, and the continuous growth rate is in the exponent what's being multiplied by t. Okay, so first thing we'll do is divide by 490 on each side. So we have e to the power of negative 0.098 t is equal to 10 over 49. Okay, now we'll take the natural log of each side. Since we have e, we have to take the natural log to get that reversed. So we'll take the natural log of e to the negative 0.098 t is equal to the natural log of 10 over 49. And then from here, we'll pull this whole exponent out. So we have negative 0.098 t is equal to the natural log of 10 over 49. Our last step here is to divide both sides by this negative 0.098. So we have t is equal to the natural log of 10 over 49 divided by negative 0.098. It's approximately equal to natural log of 10 divided by 49 divided by negative 0.098. It's approximately equal to 16.217. And that's the final answer there. Okay, the last page, our last problem, problem 5, rewrite the given logarithms in terms of the natural log and calculate its value using your calculator. So here we have to use the change of base formula in order to get the proper base. So we'll have the change of base formula is that the log of b raised of x is equal to the ln of x over the ln of b, or you could use the log of x over log of b. Either rule will work. So for problem A, we have the log of 5, or the log base 5 of 8 is equal to ln of x is 8 over ln of 5. And you just go ahead and plug that into your calculator, and you'll get ln of 8 divided by ln of 5, about 1.292. And then the last problem here, we have log of 3, base 3 of 12 is equal to the log of 12 divided by the log of 3, which is about equal to 2.262. Okay. And that's it for today. I will stick around for any questions if you have any.